So ladies and gentlemen, I want to say a big welcome. Today we want to look at time series forecasting. By the time we finish, you should know how to do forecast using some methods. You should know how to do forecast using some methods. You will understand what affects forecasting. There are two things that affect forecasting. You will learn them. You will learn them. And then there are several methods that are used for forecasting. You will learn 4 of them today. You will learn 4 of them today. But first, let's ask some questions. A simple one. What is a forecast? I want each one of you to give me a synonym for forecast. What is a synonym for forecasting? Each person should give me one. Give me one synonym for forecasting. Please, let's be quick about this. Don't delay. Be quick. Give me a synonym for forecasting. Projection. Future estimation is not correct. Projection is correct. Prediction. Okay, I want the noun form of things. Okay, give me more. I need a synonym for forecasting. Stop Googling. What is it? It should be one word. A synonym for forecasting. It's not guessing. What's a synonym for forecasting? Foretelling. Okay, I will take foretelling. Okay. And please, some of you who are writing the same thing others have said, you shouldn't write that, because if you are observant, you know that others have written. Foresight. Okay, foresight. Very good. So that is forecasting. It's a prediction about the future. A prediction of what will happen in the future. Keep notes. A prediction. Write it down. A prediction of what will happen in the future. Now, where can you apply it? Where do you think we can apply forecasting? It happens where? Where do you see that somebody, a group of people, or somebody is predicting something that is going to happen? Where do you apply this? Give me an area. Okay. Prophecies are bogus. You're not talking religious prophecies. Yeah, that's not forecasting. It has no calculation there. It has no proper analysis. It has no analysis for you to come and say that is forecasting. Prophesying is nothing. No, please don't go down that path. Give me an example of areas exactly, Manala Champo. I love that. Okay. That is a weather. I mean, meteorology. You do forecasting. Fantastic. That's better. Okay. But no lotto. No lotto, please. Lotto is not. Puta. Okay. Football, sport, very good. In sport, many people do forecasting. Okay. They do a lot of prediction because they have a certain specific procedure for doing those predictions. Okay. Forecast, financial market, very good. Okay. In stock market, you do a lot of forecasting there. So what are people forecasting? They're forecasting success. They're forecasting winning. They're forecasting gains. Okay? They're forecasting winnings. They're forecasting gains. They're forecasting demand. They're forecasting profit. They're forecasting, something that brings happiness. That is forecasting. Okay? And these are the areas you can apply forecasting. If your forecasting is poor, customers may insult you. If your forecasting is poor, inventory will be poor. If your forecasting is poor, complaints will come. If forecasting is poor, there will be shortages. There will be a lot of things that people will not even. There will be shortages when you cannot actually predict the demand. So forecasting is necessary for success of any company. Now, managers use forecasting when they are doing judgment. Managers use forecasting when they are doing expert opinions. Managers do forecasting. Oh, by the way, when we talk about expert opinion, there is something called the Delphi method. It's a very powerful way. What it does is that it predicts the future using informed judgment, opinions of knowledgeable people. It will do a survey from specialists, knowledgeable people, and then it will project something that is going to happen. Okay? This is the Delphi method. It's an expert opinion. Managers use that a lot. Managers can also use their past experience to tell the future. Well, I think the last 3 years, because we did it like this happened. So based on that, I think they use past experience. Some people are using technology, AI. AI is helping a lot of people to do forecasting. But one of the key processes of forecasting is mathematical and analytical methods. Mathematical and analytical methods. That is what we use for forecasting. And two of them are time series and regression. Time series and regression. Today, we are going to look at time series. Next time, we'll look at regression. Guys, are you ready? If you're ready, type Y. 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 Type Y, type Y, type Y. I need to feel you. I need to feel you. This is the last, lecture you're going to have with me before your holidays. You got to feel me. I got to feel you. I got to feel you. I got to feel. I got to feel you. Type. So what are the components of forecasting? There are two major components. You see, whether a forecast will be good or bad depends on two things. Write them down. The first is the time frame. The second is the pattern. The first is the time frame. The second is the pattern. The pattern. The pattern. Okay. That is how you do it. What is the time frame? Well, the time frame is that planning horizon, the period you want to forecast. So maybe you want to forecast using short range. Okay. Maybe you want to forecast using short range, like 1 to 2 months. So you are using the past 1 to 2 month information to predict the future. Or you want to use medium range, 2 months to 2 years. You want to use that to be able to predict the future. And a lot of people do this in election. This last time, this is what we did. This is what happened. This time, this is what we should do. This is what will happen. Okay. And then long range. Long range is done a lot in investment analysis or stock market analysis or currency market analysis. Long range forecast, more than 2 or 3 years. And that is the time frame. Look, if the time frame is longer, it will affect the results in a way. If it is shorter, it will affect the results in another way. The next thing, and this is key, this is very key, is the pattern. You see, the pattern of the forecasting method or the patterns in real life will affect the forecasting method. I want to repeat that, and you want to write that down, write it down. The patterns will affect the forecasting method you are going to use. I'm going to mention a couple of them. And you will see that some of the forecasting methods we are going to talk about, certain patterns will not help them. But other forecasting methods, certain patterns will help them. One of the patterns is a trend. What is a trend? A trend. A trend. You see, we use that language, but we cannot distinguish between a trend, a season, and cycle. A trend, a season, and a cycle. And even the worst of it all is random noises or random variabilities. These are the patterns you must know. Can you tell me what each one of them mean? Well, let's take the first one, the trend. The picture you see on your top left, the picture A, is a picture of the demand for a certain product being affected by time. So you can see in this context that as the time is increasing, okay, as the time is increasing, you will notice that demand is rising, but then there are random movements. Now, if you check here, the movement happened after the first rise. Then there's a brrr, then there is one rise. It's not rise. So there is a trend which you can see here that is rising. Okay? You can see a rising situation. So one thing about a trend is that it has a long-term up and down movement. Long-term up and down movement. Take note. That's a trend. Up and down movement. Long-term. And those up and down movements there could be random movement in between them. There could be random movement. And you can see that one of the random movement is up. You see, it's very high up. And one of the random movement is very high low. So that is what we mean by a trend. It is a rising trend. Well, this one is a rising trend. It could also be a falling trend. But the key point is that it has an up or down movement. It is gradual, up and down movement. That's not the same as a cycle. You see, the thing about a cycle is that it's not rising. You see, if you look at a trend, it's a rising up and down movement. But a cycle is up and down movement, repetitive movement, up and down, repetitive movement. But it's not rising over time like a trend, or it's not falling over time like a trend. But you rather have what? You rather have up and down repetitive movement, up and down repetitive. So there is, it's oscillating. It's oscillating. It's fluctuating. That is a cycle. That is also not the same as a season. A season is also up and down repetitive movement like a cycle, but it is within a trend. And it occurs periodically. There is a periodic occurrence. So you know that every period of time that will happen. Evening will come. Every 24 hours, evening will come. Every 24 hours, evening will come. Okay. And you can have the same thing with Christmas. It's a seasonality pattern that you consider. Watch it carefully that we know when that thing will happen. It's not like a cycle, which is just up and down movement. When it is not clear when the up will come. No. But this one, season, it is clear when the up will come. And then the final one is the funniest one. It is also a seasonal pattern, but it has a trend. You see, a trend is something that is rising or falling. And so in this case, you can see that it has a trend. And it is seasonal because it is rising. And then there's a sharp rise. It's rising. Then there's a sharp rise. It's rising. Okay. Of course, when I say it's rising up and down. So it's rising up and down. But then there's a sharp rise. It's rising up and down, but it's a sharp rise. That is not the same as a trend. You see, a trend might be rising, but there is a down and then up. But here there's only up because it carries with the seasonality pattern. Understand all of these patterns. Why? Because they can affect the computation of forecasting. You're going to see that as we move on. So let's look at the methods of forecasting. What are the methods? There are three main methods. One of them will not even look at it because that one is judgmental, it's qualitative. The first one is time series. The second one is regression. The last one is qualitative. The qualitative uses hunch. See, there are four sides to the human eye. You have four sides. Okay. The first one is hindsight. There are four sides. Okay. The eye is the medium through which the human being can see things. Okay. And there are four sides to the human being. You have hindsight. You have foresight. You can tell me the other side you have. You have hindsight, the ability to be able to see something based on what you have felt before. Foresight, the ability to be able to see something based on what you already see ahead. Then you have oversight. Oversight. And who can tell me the other side? Insight. Insight carries the idea, okay, of going within to be able to see the without. Carries the idea of discernment. The foresight to the human eye. Many people don't have. The ability of a person to be able to look at the past behavior, to predict the future behavior. That is what is time series analysis. It's a mathematical statistical technique that uses the past behavior to predict the future behavior. And that prediction is purely based on time. So you are predicting the future based on only time, not based on any other thing. Time, time, time. So what you are saying is that what is affecting your demand is going to be time. Time. That is only the same as regression. You see, in a regression, you have a dependent variable, which is a function, depends on some independent variables. And the independent variables are said to be influencing the dependent variable. Let's take, for example, price and quantity demanded. The quantity demanded of any commodity in this world is affected by the price. So the price is the influencer, the independent variable. And the quantity demanded is the recipient, the response, and hence the dependent variable. So you try and establish the relationship, and after establishing the relationship, you will use the price, which is the independent variable, to predict the quantity. You will use the independent variable to predict the dependent variable. In other words, if I know the independent variable, how much would the dependent variable be? What would be the predicted value of the dependent variable? That's regression. We'll look at that next time. I want to focus today on time series forecasting. Time series forecasting. Please have your pen ready. Please have your book ready too. Let's start with the time series. The first, we're going to look at 4 of them. The first time series forecasting method we are going to look at is moving average. Everybody type MA, moving average. Moving average. Moving average. Type MA. Be part and participate in your own understanding. As you type, there is an information symmetry that is between your fingers and your brain. So you activate your mental gymnastics as you type. So please do that. What is moving average? It uses the recent past, not just the past, recent past to develop the forecast. And it creates something called a dampening factor, a smoothing factor. So it smooths out, smooths out the random rise and falls in the data. It's very, very useful. When you have a data where there is a lot of stability, this is good. I mean, we don't have a lot of, shocks, but we have a lot of stable situation. This is good. How do you calculate it? It's very simple. This is a formula. The moving average of any particular period. So let's say I want to calculate the moving average, okay, of any particular period. Let's say period 4 is going to be take each of the orders that you are dealing with, or demand, whatever it is, whatever item you are doing, which you are trying to predict, take each one of them, add them together. So if you have D1, you add the D1 to the D2, you add the D2 to the D3, all the way up to the D4. Then you divide it by the period, which in this case is 4. That's it. And that will give you the moving average for the period 4 that you are trying to do it. We're going to take a typical example and then work it together. You will do the working as I give you the guidelines. Okay. So when you see this formula, don't get scared. That's what I've just interpreted. Okay. So what is the average of 2 plus 4 plus 4? What is the average? No, let me make it simple. What's the average of 2 plus 4 plus 6? See, normally you give the answer, but you even forget how you got the answer. What's the average of 2 plus 4? What's the average of 2, 4, and 6? It's 4, right? It's 4. How you got a 4, I'm sure you know it. What you just did is average calculation. So do not be scared, okay, about how to, when you see some of these formulas. So let's try and take a typical example of the data set and see how it works. So I have a 10-month data on a product. It is for a company known as Paperclip Supply Company. You can see that in this data set, I have the orders. So people are ordering. I have the orders for January, February, March, all the way up to October. I don't have the order for November. And I want to predict the November order. But in the process, I'm going to use a moving average to do the prediction. So the question now is, find the 3-month moving average for November. For November, remember the formula? We are finding the 3-month, not a 4-month, not a 6-month, not a 7-month, but 3-month moving average for November. So if you want to find for November, how are you going to work that? You have to use some things in the past before November. And they said you should use a 3-month moving average. Who has found it? Calculate it and let me see. I want to see the smartest people among you before I even show you the answer. Because I always know there is at least one smartest person among the crowd. Quickly, give me the answer. Okay, Harmony has written his answer. Gertrude has written the answer. Rabbi has written. I've got 3 different answers. Ooh, this is getting interesting. Salom has done it. Robert has done it. Daniel has done it. Others are doing it. Good. You always have smart people. I've got almost 6 people getting the answer correct. Belinda, Daniel, Gloria, Reginald, Daniel, Brandon. So how do you do that? It's okay. Those of you are behind. The way to do that is to write MA3 because we are told to do a 3-month moving average. And then because you are doing it for November, you have to write that of October 1st and go backward 3 times. So you take 90 for October, you take 110 for September, and then you take 130 for August, and you divide that by 3. That is your 3-month moving average. Okay, and I'm sure that those of you who watched it, okay, you know why. So that is 110. Most of you got that. Now find me the 5-month moving average. This time, now that you know the approach, for November, find that. Find that quickly. Let me see. I want the first person. The first person. Speed is of the essence in the game of knowledge. Excellent, Gertrude. Gertrude was the first person to crack that. If you do that, you're going to get 91. And Gertrude got that first, 91 orders. So what it means is that for November, the orders, if it is a 5-month moving average, the orders will be 91. But if it is a 3-month moving average, the orders will be 110. So do you realize that the type of period you select, whether it is 3-month moving average or 5, and that period you select, the kind of period you select to do your computation will affect the results you'll get. Okay. If it is a 4-month moving average, again, you will know what will happen. So that's it. That's how you calculate moving average. What are the advantages? Well, let me share some few things with you. By the way, you can do this in Excel. Let's do this in Excel first, the 3-month and the 4-month. Okay. So let's go to Excel. And I think I gave you guys the data. Okay, so this is the data. Yeah, I'm just going to take do with a brand new information here. So just watch here. So these are the orders. How do you do it? As it stands, we are going to just do for, let's call it n equals to 3. So this is for the 3-month moving average, okay? Where we are looking at MA3. You would always what do you call it? You would always remember to start, you ignore the first year anytime you are doing it. Okay? You ignore the first year because it will not have anything from its back. Okay? So remember that when we are looking at November, we started from October. So when you go to January, there's nothing to look back. There's nothing to have from December for you to use. So you ignore that. So how do you start a calculation? You go to Data tab, and on the far right, you select Data Analysis and select Moving Average from the list. You see it in blue, Moving Average. Click on it, click OK. A pop-up will show. In that pop-up, you're going to select all the data, including the title, orders, up to October. You don't know November, so don't include November. Then you will take labels in first row, because you selected the first name, which is the orders. Then under interval, okay, I'm going to type 3 because we are looking at 3-month moving average. Then the last one is to indicate where your results should be. And in the results section, you're going to ignore the first one, which is January, and start from the second one. So I selected C3, cell C3. Also, you can click on the chart so that you see the graphical interpretation of the results. Let's look at the results. Okay. So you can see clearly that we now have the moving average, 3-month moving average for each period. Okay? And for November, we now have the 3-month moving average also for November, which is 110, which is something you all had. Now look at the graph. The graph will show you the moving average, the actual values. So the actual values are the orders, okay? And then the forecast values are the moving average. You can see that for most of the time, it appears that the forecast is below. If you look at it, for example, this last 3 before the last one, they are quite inside or below. Okay? And then this one is below, and then these 2 are above. So first 2 are above, next one is above, and then the last one is above. But these ones seem to be, okay. So generally there seems to be, the forecast is not perfectly equal to the actual demand. But the most important thing is that you've been able to look at November, and November's order is 110. You can do for, that was the name. You can do for the other firm, the other moving average, which is 5. So you can change your N to 5. And once again, you go to Data tab, you choose the same thing, everything. The only thing is that this time you change the interval from 3-month moving average to 5-month moving average. Okay? And then change your output range, okay? Because the output range is C3. But now the column we are looking at is D. So you start from D3 and click OK. And you can also see that the results come along with it. Most of you had the 5-month moving average to be 91 for November. And you can clearly see that truly it is 91 for November. And then there's a graph for that as well. So what can you say between the 3-month and the 4-month moving average? Can you say? But there are some few things you can observe if you are very observant. Okay. Let's look at the results properly. Then I can tell you some interesting things about the results. By the way, this is a result. similar to the one we found in the Excel. What is your conclusion? Look at the results. Okay. For example, starting from June, where they all have numbers, you will notice that the 5-month moving average is bigger for June than the 3-month. Okay. July, the 5-month is bigger. August, the 5-month is bigger. September, the 5-month is bigger. But October and November, you will see that the 3-month is bigger. And we are more interested in that because, especially the November, because the November one is the one we were forecasting. So when you look at the November one, you will notice that the 3-month moving average is bigger than the 5-month moving average. So what can we conclude? And of course, this is a graph for that. What we can conclude, and those of you who sometimes come to the class and you vamoose, I will take a row count. So take note. But the first thing is that longer period moving averages react more slowly to changes in demand than shorter ones. So longer periods moving average, they are more slow reactors than the longer ones, than the shorter ones. Also, the number of periods, I chose 3, you can choose 4, you can choose 5. It's all try and error. So you have to do try and error until you get a 1. That will give you a bigger value. But the bigger value is not the issue. You have to calculate something we'll do next week, which is called forecast accuracy. So you got to know how accurate the 3-month moving average is compared to how accurate the 5-month moving average is. When you know which one is accurate, then the one that is accurate is the one you choose. Now that approach will calculate error in each one, and you look for the one with the smallest errors. Another thing is that the moving average does not react well to trends. We said it before. We even said that the moving average is used when there appears to be no trends. But the good thing is that it's easy to calculate, so why not? It's quick, easy, it's very, very cheap. So you can do that easily. So that is the moving average, okay? And one more thing is that when you want to calculate for December, you see right now, we have November, we don't have December. But we also don't have November, we just calculated November. So if the forecast is for longer periods than one period, suppose you are forecasting many, many, many periods, okay, then the forecasts can be used. So you're rather using the forecast as the actual demand to calculate the forecast for the next period. So if you take November like this, we didn't have actual demand. So if I want to calculate for December, what do? You have to use November's forecast, not the November's actual demand, because I don't have the November's actual demand. So you will use November's forecast, to do for December. So, to forecast for December. Then when you finish, you don't have actual demand for December. So you have to use December's forecast you just did to help you forecast for January, like that. However, the data should be updated. The moment you get the actual demand, the moment now you know the actual demand, you have to update the data, okay, so that you can update your results. Yeah, forecasting must be done all the time. Some people do daily forecast, though. Stock market analysis, currency market analysis, people are doing daily forecast. Some people do weekly. Some people do monthly forecast. Some are doing yearly forecast. Some are predicting their GDP for the next 50 years. So it's a very, very important subject to look at. Okay, so that's the first one, moving average. Who has a question? If you have a question, please ask now. Great. Let's go to the next method. Now, I want you to know that each of these methods, we are learning all of them. At the end of the day, in real life, what do? Which one do you select? Which one do you choose? At the end of the day, you have to check the error in each one, the forecast accuracy. And the one with the smallest error is selected. So let's look at the second time series method for forecasting. It's called weighted moving average. As the name sounds, you have to weight the others. You have to weight the demand, weight the others, weight the demand. So you take each one. So you may have demand. So suppose I want to calculate moving average, weighted moving average. Okay. And I'm calculating for maybe the first two. First of all, I must know the demand for the first one, and then I must know the demand for the second one. I must also have the weight for the first one, and I must have the weight for the second. What is the weight? The weight is the importance you attach to the value, the orders, the actual orders, the importance. So if you think that there is more importance to the first order, the most recent order, than the distant past orders, then you are going to give the most recent order a higher weight. Oh, by the way, the weights are always between 0 and 1, and they will add up to 1. Okay. The total number of weights will add up to 1. So if you give the first one, if there are only 2 orders like this, and you give the first one a weight of 0.7, then the second one will have a weight of what? So the first one has got a weight of 0.7, then the second one will have a weight of what? 0.3, exactly. That's how you do it. Now let's take an example. Okay. Now remember, we are not going to use our data. I've indicated that the sum of the weights is equal to 1. I'm rather going to pick a sentence and then edit it slightly. So that paper clip that we had before, okay, let's assume that the weight for October is 50%, 0.5. The weight for September is also 33%, 0.33. The weight for August is 17%, 0.17. By the way, when you add all of them, you get 100. Okay. Question is, given these weights, and by the way, you should want to write these percentages down. Given these percentages, you are to calculate the weighted moving average, because the weights have been given to you, they are in percentage. Calculate the weighted moving average, and these are the orders. Okay. Don't forget that these are the orders. The orders are here. The others are here. Calculate the weighted moving average for November. Who has finished? The weighted moving average for November. I'm waiting to see who is ready. Nobody has got it? Are you struggling? Do you need any weights? Okay, I got one person. I'm saying you should calculate the weighted moving average for November. Remember the weights. The weights were 0.5 for October. The weights were 0.33 for September and 0.1117 for August. Anyway, you can do this thing, right? Let me just check. So you just take each one and multiply it by the others. That's what you do. Okay. And you get this. You get 103.4. So you take the 0.5, multiply by the order, 0.33, multiply by the order, and then you can get this amount. That is how you solve for this. That is how you solve. It's very simple. Okay. I can also ask you, you see, before I ask you anything, I must have given you the weight. And if I give you 2 weights and I'm asking you for 3, weighted moving average 3, then I expect that if I give you 2 weights, you should be able to find the last one by subtracting the combined forces of the 2 from 1. All right. Let's go to the third approach. And this is where it gets a bit tough. So pay attention and ask questions. We've looked at the moving average. We have looked at the weighted moving average. Okay. Now, the third approach is known as the exponential smoothing. Exponential smoothing. Pay attention. Smoothing. Smooth. It is also an averaging method like the other ones, but it weights the recent past data more strongly than, of course, the distant past. So I want to repeat. It gives more importance to the recent past than the distant past. So I'm sure you know what I mean by recent past and distant past. They are all past. So when you look at November, which one is the recent past order? And which one is a distant past order? Give me one example. If you are looking at November here, what is the recent past order for November? And what is the distant past order for November? The numbers you guys are writing doesn't mean anything. Friends, you have now written the best answer. Okay. So 90 is so which one is a distant past order? Which one is the distance past order? No, it's any other. Any other one is the distance past order. It's not just 120 alone, but anything that is not a recent past order is a distance past order. I didn't say the most distant past order. Of course, the most distant past order is 120, but then the distance past order can be 110, 130, 75, and all of that. Okay, so what this exponential smoothing does is that it gives more weight to the recent past order than the distant past order. Basically, that's what it does. Okay. Now, there are 2 of them. Oh, by the way, the weight. When I say the weight, again, the weights are between 0 and 1. Okay. So if it gives, let's say we are talking about just 2, and it gives 75%, okay, to the recent past order. It gives 75% to the recent past order. Then the other 25 will go to the distant past order. There are 2 weights. And by the way, the weights are automatically determined. They are determined, subjective. Somebody said, normally, how do you even get a weight? Okay. The weight, there's more weight given to the recent than in the past. So exact one is subjective. Okay. There are 2 forms. One is simple, exponential smoothing. The other is adjusted exponential smoothing. One is simple and hence easy to calculate. The other is adjusted and not easy to calculate. So pay attention, because these are the only two we are going to do for today, and then we are done. If you can understand this, you can answer exam. There's always exam question on this. All that we are doing, there's always exam question. Okay. Aurelia, can somebody call Aurelia's phone and tell her how she's disturbing everyone here? Can somebody call her? See, that's when I know when a person is serious. Because if the person is serious, the person is not intervening. And the person must have known by now, because the person is talking. Okay, let's look at a simple exponential smoothing. This is a formula. Please, everybody write it down. Please, write the simple exponential smoothing formula. The simple exponential smoothing formula. And when you are done writing it down, I need the 5 people who have done that to type yes or Y. When you are done with that, type Y, so that I know that I have people with me. Okay, good. So what is the ft plus 1? What is this ft plus 1? As you can see, this is the forecast for the present period. The present period. And this ft is the forecast for the previously determined past period. Okay. Now, the interpretation of them are here. So the forecast for the present period. Okay, so you see, I use past for this and I use present for this. But it says forecast for the next period. So then if this one is the next period, then this one, it becomes a present period. So it depends on which way you look at it. So if this one is the next period, then this ft is the present period. Now, actually, this is the truth. T plus 1 is the next period, and then T is the present period. Now, this D is the demand for the present period. The demand for the present period. So T, subscript T is always present. The demand for the present period. You're going to use this formula. That's why it's important you write it. Okay. The next thing to do is to know the alpha. Okay. The alpha is the weighting factor, the smoothing factor. Take note, it's a smoothing factor. I've already told you that the FT is a previously determined forecast. So remember, so this FT is a forecast, but a forecast you got from the previous period, but it's now for the present. Okay, it's now for the present. So, and of course, you have the actual demand, which is the present actual demand. The alpha is how much importance you have placed on the actual demand, the demand for the present period. And 1 minus the alpha is the rest. Now, when we go to Excel, and we'll go to Excel later, you will note that Excel rather uses the 1 minus alpha. So you have to write the 1 minus alpha. It doesn't call it a smoothing factor. It calls it a dampening factor because the opposite. So the smoothing factor is 1 minus the dampening factor. Write it down. And the dampening factor is 1 minus the smoothing factor. The weight. So with this formula that you've written, okay, I'm going to give you a data set, then we'll start solving. But before that, note something here. That the forecast for the present period is always the current demand. The forecast, take note of this. And maybe you should even ask me why. The forecast for the present period equals the actual demand for the present period. Why? Because if you are looking for the forecast for the present period today, you don't have anything from yesterday to use because the data you have starts from today. And so the forecast for today will simply be the actual demand for today. So take note of that very, very importantly before you start getting confused. All right. Every other thing will use the previous ones because you know them. Okay. Now, which alpha do you use? The popular alphas are between 0.1 and 0.5. But I've said it that alpha is subjective, it's try and error. You just choose whichever alpha you want to choose. After all, it's between 0.1 and 0.9. The common ones are that, because as you go further, you realize that it's not of no use again. Okay. And once you've done that, you can check which one gives you the smallest error. And once you know which one gives you the smallest error, you are now sorted. You are ready to go. So let's take a typical example of a data set. PM Computer Services assembles customized personal computers. The most important thing is that they combine computers mostly at night from a lot of sources. So what they are doing is that you give them the parts, and when they get the parts, they put the parts together. And they want to know how many computer parts to buy and stock. They might buy the monitor, they'll buy the mouse, they'll buy the keyboard and things. They want to know how many parts to buy and stock. They've accumulated the demand for the computers for the past 12 months. They put it all together. So when you look down here, the demand for the first 2 months are here, 12 months. So in period January, the demand was 37 computers. In February, demand was 40 computers. And in December, demand was 54 computers. Now we want to know demand for January. But of course, we need to know the demand. We want to forecast demand for January. But we need to know the forecast for the previous month so that it will help us to even know demand. So why? Why is that so? Because when you look at the exponential smoothing, if you want to know the forecast for January, you must have the forecast for the one before January. And if you want to know the forecast for the one before so if you want to know the forecast for January, you got to know the forecast for December. Not the demand for December. As for the demand for December, you have it already. But you want to know the forecast for December. Okay. But if you want to know the forecast for December, you have to know the forecast for January. But if you want to know the forecast for January, you got to have the forecast for October. But if you want to know the forecast for October, you got to know the forecast for September. Even though you have the demand for September. But if you want to know the forecast for September, you got to get a point. Oh, dear me. So that is how you do. So we are going to calculate the forecast. So let's look at the question first, how to calculate the forecast. Now you have been told to do for February. So the question is saying that find the forecast for February and March, and then do it for all the months. Then we should also know the forecast for the next month, which is the next January. Okay. But first we need to do the forecast for February because of March, we need that forecast. We need to do the forecast for March because April will need that forecast. And the smoothing constant, do for alpha equals to 0.3. Use 0.3 throughout. Then when you finish, come and use 0.5. So you are using 0.3 all the way through. When you are done, come and use 0.5 all the way through. Of course, we are not going to do all the way through. I'm just going to do for February and March. Okay? All right. We are going to do 0.3 and then you do 0.5. Let's start. This is our data set. And this is the smoothing constant. So keep in mind, we are just going to do 0.3 for now. We want to know the forecast. So it's like if I were to create a column here, we are looking for FT plus 1. That's what we are doing. the forecast. And there's a formula there. So my question I want to ask you, fellas, I want to ask you a question that given this, what do you think would be F1? Okay. If we're to do F1, if you look at the formula says that it should be alpha D, but the D should, in this case, will be D0. Okay. Plus 1 minus alpha. And then F should be for the past. Okay. And that will be F1, what do you call it? T minus 1, which in this case it will be F0 because we are 1. So we need to go to that F0. So what do you think will be, and that means that we have basically nothing. I'm even giving you the answers. So what do you think will be the forecast for January? Let's start with January. What do you think will be the forecast for January? Look at January. If we were to forecast for January. In fact, I shouldn't even write January as F1. I should write it as F0 because the question says that we should do, what did the question say? The question says we should do, F. So what's the forecast for January? Let me see. Yeah, I know you're all writing 0, okay? And it's actually 0. Okay? The forecast for January is 0 because there's nothing for January. Okay. So let's do the forecast for February. The forecast for February. How will you go around it? The forecast for February, that's the one I should actually call it F1. Okay, that's the one I should actually call F1. If I were to do the forecast for February, it is going to be, basically, it's going to be alpha. I'm calling it F1, but I don't know if I should call it like that, but I'm calling it F1, I don't know. Okay. But the forecast for February is going to be alpha D for January. Okay. Which is plus 1 minus alpha. So first of all, alpha is 0.3. Okay. And January demand would have been, what's January demand? January demand is 37. Okay. 37. Then plus 1 minus 37. 1 minus 0.3 is 0.7. Okay. Then you have the forecast for January. I don't know what name I should call this one. I keep saying I don't know what name. So I'm just going to just change it. The forecast. Okay, so here's the thing. Because we don't have a forecast for January. Okay. Because you don't have a forecast for January. The forecast for February, and I don't know whether I should call it F2 or what, what, will be equal to that of the actual demand for February. Actual demand for January. Take note of this. Write this down. If you want to ever find the forecast, okay, for the next period, because remember, even though I've written 1, it is actually T plus 1. That's why I shouldn't write 1. So it should be F T plus 1. and in T is 1, which we did before. Okay. And so ft plus 1 will be alpha dt plus 1 minus alpha, and then ft. And now we know that t is 1. So t plus 1 will be 2. Okay. T plus 1 will be 2. So that will be equal to alpha, which is 0.3, and then dt. And what is the dt? The actual demand for I'm calculating for February, right? I'm calculating for February. So actual demand for February, no, I'm calculating for February. So the actual demand will be January, okay, because it is T. And that will be for January, not February. And that January is 37, isn't it? So you're going to have 30. That's here. I'm calculating for February. And then plus 1 minus alpha, and 1 minus alpha is 0.6, 0.7. Into bracket, the forecast you had for the first period, which was, in this case, what was that? In this case, it was 37 as well, okay? Because remember, the forecast we had for that would be 37 as well. So then we have 37. So what would that be? We have 37, 37. And then you divide, you still get 37, isn't it? So you're going to get 37. That is what you get for February forecast. So this is where it gets slightly tricky. That is for February forecast. Yes, Emmanuel. Emmanuel,
So
go ahead.
I have a question. For the forecast for January, we got 0. So why are we saying it is 37 when we are calculating for February? Because F1 in F1, which is the forecast for January, we calculated it as 0.
We didn't calculate it at all. We didn't have any forecast. To be honest, we cannot calculate a forecast for January, because January has nothing following it. It's not 0. It's just not there. So the only thing we can do with it is to dash it. When I say dash, give it a dash value. You can't actually say it is 0. 0 is something that is available, but then the forecast for January is simply not available. So maybe your question should rather be the second one. Your question should rather be the second one, because looking at the formula says that the forecast for the next period should also take the current period. Okay, the forecast for the next period should take the current period. What is the forecast for the next period? The next period is February, right?
Yes.
Okay, so now if the next period is February, alpha is 0.3, 1 minus alpha is 0.7. So you understand that. What would be D1? Because DT means D1. And we are calculating for February. So we are calculating F2. So what would be D1? D1 will be 37, which is already in the slide, isn't it?
Yes.
That is actual demand for January. So that is D1. And then plus 1 minus 0.3, multiplying the forecast for what do you call it? The forecast for January. Now remember, previously we said that January, there's nothing there. And now the forecast for January, I have used 37 again, isn't it? And the reason is because anytime you are calculating a forecast and you do not know the forecast value for a particular number, the previous value you know becomes the forecast value. But you cannot use that to calculate the forecast for January. I want to repeat that. Let me repeat what I just said. As for January, listen carefully. As for January, you don't have its forecast value at all. You don't even have it. When I say forecast value, you see, when you're calculating the forecast T+1 for January, you don't have that of December. Because FT will be December if you're calculating for January. But you don't have it. Not that it's zero, because you just don't have it doesn't mean that it's zero, because you just don't have the data. Does that make sense? You see, sometimes we make it look like when you don't have something, then the thing is zero. It's not zero. You just don't know. So the FT value, if I was to do January, I don't have the FT value, which is the December. That is why I give that January a dash. But when you come to February, the DT value is 37. Because remember, when you are calculating for January, the DT value is January. So when you're calculating for February, the DT value is January, which is 37. Now, what about the FT value? Well, first of all, I know the DT value. And you remember I said it at the end. Let me just go back here and then show you something here. We said it here that, look at this one. Do you see this thing? You see this thing I've circled? Is the guy with me?
Yes, sir, I'm here.
So
I understand now.
We indicated that always use F1. If you want to have the F1, use D1. So what is F1? F1 is the forecast value for January. Because now I'm calculating February, okay, which is F2. So F1, I should replace F1 with what? With D1. Remember, I told you that when we get here, you guys might be slightly confused, and there you are. So yeah, that is why I still use 37 to replace the F1 value, which makes you now feel like, but we said we didn't have the value there, but how come we got it? I hope you get what I mean.
Yes, sir, I understand. So it means we only have this problem with the first month.
That's
always.
It. Only with the
first month, we always need to assume that the forecast for the first month, when we get to the second month, is the demand for the first month. So yeah. I understand.
It's only the first one. Okay. Subsequent ones, you see that we have the forecast value, so we always use those forecast values. Okay. So that is how you get for this. So you get 37 for the February. Okay. That's a forecast value. Now you see you have the 37, which is F2. You have the F2 value. So when we go to March, what do you think March is going to be? March is going to be F3. 0.3 times what? It's going to be 0.3 times something plus 0.7 times something. What is the first something? 40. Yeah, some of you are typing. And then the second something. Now remember that second something is going to be F2. And what is that? See, by this time, you have that F2 here, which is 37. So you can now slot that 37. But the reason why when we're doing the February, we didn't have that, but is because we didn't have anything for January. And so we use the current demand only for the first period, only for the first period of calculation. Anyway, so when you calculate this one and you solve this, you're going to get a value that is 37.9 units. So that is the forecast for March. And so when you're calculating the forecast for April, what will you have? You're going to have 37, that is 0.3 times 37, plus 0.7 into bracket 37.9. That's how you're going to have for April. And then you keep going and going and going on and going. That's it. If you don't have an understanding right now, you can let me know. And I'll go by it. Okay. So now you can do that calculation for 3 and all the way to the end. And then you can also do that calculation for 5 when you're done all of the 3 and then all the way to the end. This is what you get. This is what you get for. So you can see that for 0.3, you get this one here, 37. And then for March, you get 37.9. If you do for this one here, and I want you to do for this one so that you can confirm yourself. Okay. If you are to use the 0.5, and it's very important you learn this 0.5 because you are going to use that 0.5 1 or something. But first, let me go to the Excel and show you how to get this. Okay. You remember, I've not shown you November. Sorry, I've not shown you the December value. Is it January? January, I've not shown you that. Okay. So let's go to this data set. Okay. I'm going to use a data set here. Where is that? Okay. So I'm just going to delete this and show you something. So when you look at this data set here, I don't know January value. I don't know the forecast for January. So I'm going to use this one also to do the forecast for January. But I need to know this first. Okay. I need to know for this first. So how do you find this very forecast? How do you find it? Well, the first thing you want to do is to go to data at the top. On the far right, you select data analysis. Remember, we are calculating simple exponential smoothing. So you have to look through, you will not see the word simple, you rather see exponential smoothing. And that's it here. The exponential smoothing that you have here is a simple one. Click it, and then collect all your data. Okay. You're going to collect all the data up to where you have a number, not the January, we don't know. Okay. Take the labels, and then you see it calls it the dampening factor. Okay. It calls it the dampening factor. But then we are using the smoothing factor. But Excel wants you to put in the dampening factor. So you have to subtract the smoothing factor from 1 so that you write a dampening factor. So that means you have to put in 0.7 here instead of the 0.3 that you yourself have written in the Excel. I hope you all got it. Okay. Then you take labels in the first row, and then you want to see where your results will be. You are starting from February, okay, because we don't know anything for December to be able to calculate that of January. So you click on that February here, and then click the chart, and then click OK. Oh, sorry. It automatically knows that you don't know anything for January. So it will make January empty by itself. So let me just go and then change where you click. So just click on January. Just click on January. It will make January not available automatically. So there you go. So look at this result. So you can see that for February, you have 37. Okay. And then for March, you also have this value, which is what? Which is 37.9. Now, how do you get January? You can just go and drag this. Why? Because the formula is already inside it here. Okay. So just drag this one, go to the bottom right of the cell, drag it down, release, and then the January forecast, when the smoothing factor is 0.3, is shown there as 51.79. Done. Now let's go to the 0.5. In the same thing for the 0.5, you go to data analysis, click on exponential, just change the, remember it's 0.5. So the dampening factor will also be 0.5. So change the dampening factor here from 0.7 to 0.5. where you want your results to be, move it away and put it right under the 0.5 and click OK. It also comes, of course, with this graph. And you can see that for this one, the formula is here. Okay. Remember that for this one, it used the first one, it used the demand, like we said. The same thing with this one, it used the demand for the second one. Now that it has gotten the forecast, going further, it used this forecast to do the calculation, as you can see. And then if you want the January, just click on the bottom right, it turns plus, drag it down, and then the forecast for January will easily be given to you. That is how you get that. So please, I want you to know how you got this 38.5. How did you get it? First, you should have the forecast for February, which is 37 here. Okay. And then you do 0.3, this is 0.5. So you do 0.5 times the actual demand, which is from February, 40, plus 0.5, that's the difference, multiplied by the forecast value, which is 37. And that will give you this 38.5. So that is how you are able to generate your forecast for each one of these values. Let's go back to our analysis. So in our analysis here, in our slides, you can see that we have all the calculations for every one of them. What is your observation? Look at it. First thing, look at the values for the 0.3 and then for the 0.5. They are all FT plus 1, but look at it. You will notice that it was 37, 38. Okay, so 0.5 is bigger. 38, 39. 0.5 is bigger. 38, 38, but then the decimal shows that 0.5 is bigger. 40, 41, 0.5, all the way up to January 51, 53. So what do you see about the smoothing constant? You will see that as the smoothing factor is getting bigger, okay, then the forecast increases. And that is a point that we have observed here, that the forecast that uses the higher smoothing factor reacts more strongly to the changes in demand than the forecast that uses the lower smoothing constant. So take note, it reacts more strongly. It gives you more bigger forecast. That's the first thing. The second thing is that both forecasts lag behind the actual demand. So when you look at actual demand, which is this one here, whether you use alpha equals to 0.3 or alpha equals to 0.5, in all cases, both of them are below the actual demand. Number 3, both forecasts also tend to be consistently lower. And I'm talking in general, because not all the time, because when you look at this one, you see that for April, okay, you see that for April, they are bigger than the actual demand. But we are talking about generally speaking, not specifically speaking. Generally speaking, both forecasts tend to be consistently lower than actual demand. And then finally, the one with the low smoothing constant is good when the data is stable, without a trend. Take note of that word, okay? Without a trend, without a trend. But then the one with a higher constant is useful when you have a trend. Write it down. The higher constant is useful when you have a trend. Because that's the next thing we are going to look at for today, when you have a trend. Okay, so that's it for the simple exponential smoothing. Was it simple? Was it simple? Yeah. Now, let's move on to the last one for today, and that is adjusted exponential smoothing. I call it AESF, adjusted. Pay attention. You see, one of the things sometimes people do is that when they are slightly stuck, then they switch up completely. But now you're in a new one, so you got to open up completely instead of switching up completely. That's how you learn. You don't learn because you don't understand this, so you can't continue. You should. Yes, Daniel, you can say a higher dampening factor produces a lower forecast. It's just the opposite. Okay. Adjusted exponential. The word adjusted means that we have the exponential smoothing all right, but we have added a trend adjustment factor. In other words, there is a trend. There is a trend. You remember what we mean by trend, right? A trend. And that trend must be included in the forecasting. So it's the same thing as before, but this time we've added a trend to it. And look at the formula, write it down. Look at the formula. So if you look at it, it is the same one that we had before. This same thing. This was what we just did before. But we have only added a trend, this thing to it. And now we are recalling it adjusted forecast. We are recalling it adjusted forecast. So once I have calculated this, I have it already. All I need to do is to calculate the trend. And then this trend adjustment factor, add it to this, and you have your adjusted exponential smoothing forecast. So pay attention. So that means that before you can even calculate adjusted, you must have all the forecast. Yeah, that's what it means. Let's try to interpret this trend thing. Let's try to understand. Okay. This trend, when it is a trend for the current period, the present period, it is T subscript T, trend. But all you can see here is that this trend here is the next period, not the present period, is the next period. Now, how do you calculate the next period? Well, before you can calculate the next period, you must know the present period trend. The present period trend. I'll show you how to calculate the trend. Now, this is a present period trend. In calculating the trend also, you will need a smoothing factor along with it. So you can see that it's not having an alpha smoothing factor. It has its own beta smoothing factor. Now, it's very simple to calculate the trend for the next period. Why? Because for you to calculate the trend for the next period, watch it, you need the forecast for that next period, subtract the forecast for the present period from the next period, which you would have calculated from the before one. And then this factor, this weighting factor would have been given to you. And of course, 1 minus the weighting factor would also be. And then you have your trend, in this case, the present trend factor. And then you can now multiply through and simplify. Once you get this, just take this one and substitute it here. As for this, you already know it already. You add a 2 and you have your adjusted exponential forecast. What is this T subscript T? Well, this is the trend, but it's a trend for the last period's trend factor. So it means that you got to know this before you calculate that. And once you calculate this one, you use it for the next one. We'll take an example. Don't worry. I've already mentioned that this smoothing constant is for the trend. Remember that the previous one, the smoothing constant we had was not for the trend. It was for the actual demand. You remember? Actual demand. Then the other one was for the forecast. So the previous one, if you can remember, the previous one, it was Ft plus 1 equals to alpha dt Okay. Then you have 1 minus the alpha ft. This was it. So that one was using the current demand and then the forecast, the current forecast, or the present demand and then the present forecast. That is how we got this, which gave us this one here. So this alpha is for the demand and then the forecast. But this smoothing constant is for the difference between the forecast you calculated here and then the one you used to calculate it. And then you have the adjusted trend. Okay. Now, let's take an example. So this is a weight that you attach to the witness. Let's take an example. And please note that the higher the value of the smoothing factor for the trend. Okay. So remember, the trend is having its own beta. If the beta value for the trend is big, it means that the trend changes more. So the trend is, the changes are happening a lot. There's a lot of trends. But if the beta is low, then the trend changes less. So look at it. Before we start adjusted exponential forecast, we must have all of these forecasts done already. So you can see that this was a demand. This was a forecast we had when the alpha was 0.3, and this is a one when alpha is 0.5. We are going to take the one when alpha is 0.5, okay? So pay attention. Look on the top there, you see that alpha here is 0.5. But then you have been given beta. Beta has been given as what? 0.3. So all of this will be given to you. So now that you know that beta is 0.3, forget about this column here. You're going to deal with the columns here. And remember, each one of them is ft plus 1. Each one of them is ft plus 1. So here comes the question. The question says, how do you calculate? In fact, okay, so you don't understand something, so I'm going to just edit something quickly here for you. All right, so focus. We are going to calculate the adjusted, okay? We are going to calculate for January, February, March, and then on and on and on. It's not going to be difficult at all, okay? If you, of course, you don't want it to be difficult, you know, it's that difficult at all. Because some of them have already been found. In fact, what you only need is the forecast. So when you look at these things here, you don't even need this alpha here. What you need, alpha 0.3, what you need is to focus on this alpha 0.5 here. That's what we need. But there are some few things that you got to understand before you move on. And the first one you got to understand is the fact that you need an initial value of the trend factor. And the initial value of the trend factor is always 0. Keep that in mind. The initial value of the trend factor. So remember, we have to calculate a trend factor. We always need to. We always have to calculate a trend factor. And when I say a trend factor, for January, take note, for January, do you remember the forecast value for January? For January. The January forecast value, you will know. Right now, here, you don't have it. But then when you're calculating for this, you should have it. You're going to see why. So first thing, we are going to create a column here. We're going to create sort of a column here for the trend, okay? And we are going to call it like T subscript T plus 1. That's what we're going to do. Before we calculate our AF adjusted, what do you call it? Adjusted forecast, AFT plus 1. Okay. The first thing you need to understand is that anytime you're calculating, the initial value of the trend factor is set to 0. And remember, this trend factor here is for the current period. What you are calculating here are for the future or the next period. Okay. So for the current period, is 0, it's not there. And why is that the case? Well, the reason why that is the case is that what we are calculating is not even the current period. The trend factor, if you can remember the formula for the trend factor. Okay, let me just go back and show you the formula. Look at it. This one, this is T here. This T plus 1 here, that is what we are looking for. And so what is the T? The T is not there. We don't have it there. We don't have the trend factor unless we calculate. And we don't have it for January. Okay. Why? Because when you look at January, it's already empty here. So the trend factor is obviously going to be what it is. However, the next point you should notice that F1, the forecast for January, the forecast for February, and then the trend for February is also going to be 0. And guys, if you want to be able to appreciate this, let's go back here. Look at the beta. If you substitute the beta was given as 0.3. Okay, this one was given as 0.3. And then that means that this one is 0.7. Okay. Now, you must have the forecast. And this forecast was calculated. The forecast, suppose we are doing for February, okay? This forecast here, go and check for February forecast. February forecast for this is 37. Okay, so you put that 37 here. That is February forecast. What's the forecast for January? January forecast is something we didn't know. And so when you take January forecast, we didn't know that. And you have 0.7 multiplying this time trend, which we didn't know. That makes it 0. Okay. And so that makes it all of this 0. That is why he's saying that for F2, for T2 is also 0. Okay. And so if T2 is 0 and F2 is 0, now we are calculating this formula here. Look at it here. This one, T2, is 0. This one, F2, is 0. Therefore, the adjusted forecast will be what? And that is the point that we just indicated to you here. So when you come down here, this point here, AF2 is also going to be 0. I want that to sink in before we even proceed. I want that to sink in before we box on. That is for the time trend. Okay, if you understand that, then we can proceed. Sometimes somebody says that you have to understand it. Okay, so T2 is 0. We've already established this. So we're going to start with T2. And because T2 is 0, all of these things are 0. So now let's go and calculate for T3. AF3. AF3. Now, this is the formula. Before you can calculate for adjusted forecast for period 3, watch it here. So this is what we are going to calculate. Before you can calculate this adjusted forecast for period 3, you have to calculate the trend factor for period 3. That's what we are going to do now. The trend factor for period 3. And just come and substitute it here. How do you calculate the trend factor for period 3? We use this formula. Okay, that will mean that we need to get the forecast for period 3 and subtract the forecast for period 2. Now, who can tell me the forecast for period 3? Oh, by the way, the beta is 0.3. What is the forecast for period 3? When you look on the screen, you can see it. What is the forecast for period 3? Look at it. It's there under 0.5. Under alpha equals to 0.5. Emmanuel says 38.5. That's correct. It's right there. Okay. So you take 38.5 and then minus the forecast for period 2. What is the forecast for period 2? It's there. It's right there. What is that? And we remember we are calculating the time trend. It's 37. Okay. Now, so you subtract the 37 from the 38. Then it says 1 minus the beta. 1 minus the beta will be the 1 minus the 0.3, which is 0.5. Okay. What? So that's 0.5. Then you go to time trend 2. Okay. What did we say about a time trend 2 up there? Time trend 2 is what? Is 0. Okay. So now that you know the time trend, if you multiply that time trend 2, which is 0, by this 0.7, and then you take this one, you're going to get a time trend for period 3. That will give you this answer, which is 0.43. Oh, good. We are done. Now that we have the time trend for period 3, I just have to add it to this same 38.5. Because remember, the formula says that when you get a time trend, add it to that period forecast, and that will give you the adjusted exponential smoothing. You see, the adjustment is just adjusted by time trend. And all you needed was just the time trend. So you now get a time trend here. You add it now, that is 0.5, to the F3, which is already up here, 38. And then that will give you the adjusted exponential smoothing forecast. You can do the same thing for F4. Now, for F4, if you look at the formula, F4, that will mean that, first of all, you need to have F3 and T3. Okay. And T3, sorry, you need to have F4 and T4. And for T4, all you need is to have the F4, which you're going to pick from here. In fact, the rest you're going to pick. Okay. And then you will take the T2. You will calculate for the T4, not T3 now. This time T4. You calculate for the T4, and then once you have that T4, you substitute it, add it to the F4, and that will give you AF4. And then you can continue on and on and on like that. That is how you calculate adjusted exponential smoothing forecast. Now, somebody asked me this question. Okay. Oh, by the way, so this is how you calculate it. The key point is learning how to calculate a time trend. Because remember, the other ones, you have it already. Okay. Learning how to. So if you do that, you're going to get the time trend for each one of this here. It's down here. Okay. You're going to get a time trend for each one of them. And you just add this time trend to the forecast, add this time trend to the forecast, add this time trend, and then you are getting the adjusted. You're getting the adjusted. You're getting the adjusted. You're getting the adjusted. You're getting the adjusted. For each one of them, you're getting the adjusted. That is how you work it out. Go and sit down. You see, this is where, when you don't fully get it, take the first example, sit down and work it step by step. Now, when you look at the conclusion, you see that the adjusted one and then the forecast one, there's some slight difference. You can see that adjusted one is slightly bigger for March. It's slightly bigger for April. It's just slightly bigger for May. And when you come to January, it's also slightly bigger for January in the end. So that's a point being made here, that adjusted is consistently higher than the simple exponentially smooth forecast. It reflects, the generally increasing trend of the data. And when you look at the data, look at it. There is some increasing trend. 37, 40, 41, 37 again, come down, but it goes up. 45, 50, 37 come down, goes up again, goes up. So there's some sort of increasing trend than falling trend. And that is what this trend factor is taking care of in the adjusted exponential smoothing method. When you actually draw it to, you see that that is the case. This is the adjusted exponential smoothing forecast. Okay. And this is for when the beta is 0.3, and this one, you can see that it is slightly above that of the exponential smoothing forecast. It's slightly above that of that. So that is how you do. So we've learned today the moving average, the weighted moving average, the simple and then the adjusted exponential smoothing. Of course, I know that the last one here is a little bit tricky. So go sit down, look at it again. When you have a question, you know what to do. I'm always there. I can attend to email. Ladies and gentlemen, that brings us to the end of the entire caboodle. Next time, what we are going to do is I'm going to look at regression. That one is easier. We're going to see how you can use regression to do forecasting. To do forecasting for all of the period and then quarters of the period. That's cool. That's really, really cool. So that's what we shall do next time when we meet.